We offer a number of degree programs, and they're listed here. But the ones you're interested in today are the BSc and the MSc in Computer Science, the BSc and the MSc in Artificial Intelligence, a new course, BSc or BEng, MSc or MEng in Software Engineering, another new course, BSc or MSc in Data Science, and we also offer a joint honours course, BSc IT with some other subject. All of these degrees can be taken with a year in industry as well. So all of these degrees can be taken either as a 3-year straight through degree or a year in industry where you do the first and second year and then go away and work in industry for a year and then come back for your final year. Okay, where to find us? As I said, we're the School of Mathematics, Computer Science and Engineering, and we're located on the Hope Park campus, which is in Chilwell in Liverpool. It's a really nice leafy part of Liverpool. That picture you can see there is part of the campus, one of the oldest parts of the university. The computing department is located on the other side of the Hope Park campus in a more modern building. I put a name up here as well, Mark Baxendale. He's the assistant head of school, and he'll be quite important to you if you come here to study. Now, we're quite a small department, but I think in a lot of ways we punch a little bit above our weight. So I'm just going to introduce you briefly to some of the key people in the department. This is Professor Atulya Nagar. He's the head of school, but he's also Pro-Vice Chancellor for the university. So we don't see as much of him as you normally would, which means that Mark Baxendale is the de facto head of school on a day-to-day basis. And you'll see quite a lot of him if you wander around the department. And you'll find, by the way, that our teaching areas, our lecture theatres and labs are all very close to our offices. So you'll see us as you wander around the place. And you can stop us and ask us questions whenever you find us, all right? We're pretty amenable. We don't mind being approached. Okay, having said that, I'm just going to introduce you to a few of the other members of staff quite quickly. This is Anicho. Everybody calls him Anicho. He's an expert in high-altitude platforms for mobile signals. This is Neil Buckley. He teaches a great deal of the first year of the degree courses here, and you'll get to know him very well. Kapil Dev, he teaches object-oriented programming in the second year, and again, you'll get to know him very well. Andrew teaches mathematics, and for those of you who are doing single honours in computer science, you'll have him in your first year. Nicholas Garon teaches quite a lot of computing, and he knows an awful lot about quantum physics. He's a really interesting guy. This is me. I've got a strange title, Professional Tutor in Mathematics and Computer Science. What this means is that I've just spent 25 years working in industry, and I've come back here to give you a workplace or industrial perspective on the stuff that you learn here. Ralph Naguib is electronics engineering principally. Anurada will teach on your first year, everybody that comes here to do computer science related things. And she teaches computer systems, CSS, JavaScript, HTML, stuff like that. Graham Reeve you may see in your first year as well. If you're doing single honours computer sciences or something like that, he teaches mathematics. And this is the associate professor, Professor David Reed. He's big into AI. He does most of the artificial intelligence, and he's also very interested in augmented reality and virtual reality. Emanuele does robotics. Pavlos is a lecturer in mathematics, so you may have him in your first year, those of you that are doing single honours or things like data science. Okay, so what have we got? What are our selling points, if you like? Well, we're modern, well-equipped laboratories. They've only just sort of been built and equipped. We've got a modern, fresh curriculum, and I'll come to that in a little while. We're lucky in that we have quite small class sizes, okay? This means that most members of staff can get to know students on a first-name basis, and we're very friendly and approachable as staff. So we'll know you by your first names. We'll see you in the refectory or wandering around the department, and you're welcome to come and chat to us any time that we're not actually busy, which is quite rare in a university, very uncommon in departments that have hundreds and hundreds of students, for instance. Now, we also have really nice facilities, really nice labs. The picture you can see here is a robotics lab. It's well stocked with loads of toys to play with if you're doing robotics. But our other labs are equally well stocked. This is the electronics lab. It's looking a little bit tidy, unusually so, I'd say. Usually it's draped with loads and loads of wires and stuff like that. And these are typical computing labs. We have a bunch of these around the department. They're large, they're airy, they have good facilities, good computers, good lecturing facilities, and they're nice to work in. The department is very research active. Last time we checked, 100% of research output was internationally excellent or internationally recognized. So we punch well above our weight, and we are 5th in the Northwest for research intensity. Teaching at Hope is also very, very good. It's highly rated in the UK National Student Survey and in all league tables. In the NSS, we have a 97% overall satisfaction rate. It's ranked 8th of all computer science courses in the Guardian University League tables of 2020. It's ranked 1st for graduate prospects in the Times Good University Guide for 2020. And Liverpool Hope is rated gold in the Teaching Excellent framework. So we pride ourselves on the quality of our teaching. And having spoken to you about our teaching, let's just go and have a little look at what we teach. All right, so in the computer science degree, what are the course highlights? Well, you're going to learn algorithms. You're going to pick up a lot of programming skills. We're going to be teaching you Java and C and Python predominantly, but you'll also be picking up some Lua, lots of C++, and some assembly language. We're going to be teaching you analysis and design skills, so object-oriented programming comes into there, and the use of tools such as UML, Universal Modeling Language. We'll also be teaching you database technologies. We'll be teaching you in your 3rd year, you'll be exposed to lots of artificial intelligence, machine learning, virtual reality and augmented reality, developing for mobile platforms, IoT, Internet of Things, and gaming. So it's quite a broad education in computer science. Software engineering is a new course, and software engineering is all about how do you build enterprise scale applications? How do you build robust applications that have to serve nations or very large enterprises? It involves lots of programming, but it's got its own things. So how do you get requirements for a solution to some problem? How do you plan to deliver it? What kind of architectures do you use to build very large scale pieces of software? It involves a lot of cloud computing these days, so we'll be looking at things like AWS or Google or Azure cloud computing. And we'll be looking at the importance of things like testing software properly, continuous integration and continuous release or continuous delivery, and how all that stuff gets built into enterprise solutions in the real world. Artificial intelligence, you'll be learning all about the mathematics for AI. You'll be exposed to artificial neural networks and associated concepts like deep learning and image processing. You'll learn to build automata. You'll be doing natural language processing, speech recognition, and chatbots. Lots of very exciting things in artificial intelligence. Data science is another new course starting this year. You'll be doing maths and stats for data science. You'll be learning R programming and doing statistical modeling. You'll be doing lots of database technology. You'll also be doing cloud computing and looking at platforms like Hadoop, because you'll be doing big data. These subjects will be underpinned by a firm understanding of fundamental programming and algorithms. Okay, so we build the foundations first, and then we build everything else on top of them. So to that point, the course curriculum, year 1, is a common curriculum. So all single honours courses share the same common syllabus in the first year, level C. I should say that IT is offered only as a joint honours degree, so IT students will follow the Core 1 block of computing studies, which I'll show you in the next slide, and the equivalent Core 1 block of their combined honours course. In your first year, we follow two basic threads of learning. The core for computer science is called CSE Core 1, Computer Sciences Core 1. And in Core 1, you'll learn structured problem solving. You'll be introduced to algorithms, and you'll be introduced to Java and Python and data structures. In your computer systems thread, you'll learn about architectures and data representation. And then you'll start to do some web technologies, HTML, JavaScript, and CSS, cascading style sheets. A thread on its own for the entire year is database technologies, where you'll look at modeling, that's conceptual and logical, and you look at practical implementation of a solution, a database using SQL, structured query language. You'll also look at how to optimize a database and how to secure a database. Those of you who are doing single honours in the first year will also do CSE Core 2, Computer Sciences Core 2 thread. And in that thread, you'll do further programming in Python and Java. In particular, we'll do lots of scientific Python, and we'll do introductions to object-oriented programming in Python and Java. You will learn the C language. There's an introduction to cryptography, and there's also maths for computing, where you'll be doing linear algebra and calculus. So that's a brief overview of what you would be doing in your first year if you came here. If you want to know anything more about the courses or the curriculums further down the line in second or third, or if you're doing MSCs or MEng fourth year, take a look at the website. The link's at the top of this page. If you go to undergraduate courses, you can search for all of these degrees: computer science, data science, software engineering, artificial intelligence, and IT. And there's some good information in there, overview of the courses, a breakdown of the curriculum year by year, some comments about entry requirements, and also some comments about possible careers you could go into after university and how well we're doing at them. I'm going to leave you with a student quote. This is from a guy who's currently doing robotics and is in second year, and he's been here during COVID. So he said, "Excellent course, which has been very flexible with regards to the pandemic, and constant communication between us and the staff has been amazing and really helped me progress and better myself despite the awful circumstances. The staff here have been working very hard over the last year to present good online material, good lectures, good seminars, and good tutorials. It hasn't been easy, but we sort of feel that the students come first. We owe you an education." Right, I'm just going to finish off with one more slide. This is kind of an overview slide of how to get in touch with us. So all the details you need to get in touch are on this slide. Inquiries to inquiry@hope.ac.uk. The website you've already seen, but go in at the top level and have a look around. There's lots of other information for students who want to come to Liverpool Hope. Now I'm going to finish there, and I'm going to hand you over to the next activity. But I hope that this presentation has been useful for you, and hopefully I'll see you come the next academic year.